So the topic for today's discussion is finding out the equivalent conductivity in the parallel connection of two rods. We have taken here two rods. One is the red color one and second is the yellow color one. The red color one rod has a cross-sectional area of A1, conductivity of K1 and a thermal resistance of R1. Whereas the orange color rod has a thermal conductivity of K2, area A2 and thermal resistance of R2. Both are having the same length X and both are connected such that the ends of these two coincides with each other and the temperature at the two ends are maintained at T1 Kelvin and T2 Kelvin. Q1 amount of heat is passed through rod 1 and Q2 amount of heat is passed through rod 2. Now, uh, the current passing through the first bar, heat current. This I1 is the heat current, I1. So that amount of heat current or the amount of heat flowing through this bar 1 or the red bar is equal to Q1 by T. T is that for time for which the heat flows and it is equal to K1 into A1 into T1 minus T2, the temperature difference divided by the length of the bar X. Now we can write this or for our purpose to be fulfilled, we can write this as we can take K1 A1 below X in the denominator. So T1 minus T2 divided by X by K1 A1 and this is analogous to T1 minus T2 by R1. We all know from Ohm's law potential difference divided by the resistance. So in this case heat current is equal to the temperature difference divided by the thermal resistance. So similarly for I2, the heat current flowing through this orange rod, it is equal to Q2 by T and that is equal to K2 into A2 into T1 minus T2 divided by X. And similarly, we can compare this with T1 minus T2 divided by R2. Now the total heat current flowing through this combination of these two rods is equal to I is equal to I1 plus I2 and therefore it is equal to Q1 plus Q2 by T and we can write is equal to T1 minus T2 divided by 1 by R1 plus 1 by R2. Okay. Wait a minute. I think I have made a mistake here. It is not divided by. It is not divided by. It is into. It should be into here. Multiply. Multiply into 1 by R1 plus 1 by R2. Okay. So now if we take another bar, of total cross-sectional area A, total cross-sectional area is A, which is equal to A is equal to A1 plus A2, right? If we take a total composition bar, single bar, and whose conductivity is K and thermal resistance is R and length is X, and the temperature difference is maintained at T1 minus T1 and T2, and the total amount of heat flowing through this is Q, which is equal to Q1 plus Q2, then we can write this equation. I, the current flowing through this, heat current flowing through this, will be equal to Q1 plus Q2 by T, which will be equal to K into A into T1 minus T2 divided by X, the length or the width of the rod. And we can write this as T1 minus T2 by R, where R is the equivalent thermal resistance of this bar. So from these two equations, from this equation and from this equation, we can compare that 1 by R is equal to 1 by R1 plus 1 by R2, right? So now what is 1 by R? 1 by R is nothing but Ka by X. From here, this was equal to R1. So, and R is equal to this X by Ka. R is equal to X by Ka. So we can write 1 by R is equal to Ka by X. Similarly, R1 is equal to K1A1 by X, and then R2 is equal to K2A2 by X. So this is our equation, and finally K cuts out from both ends and taking A downwards in the denominator size, K is equal to K1A1 plus K2A2 by A. Now if there are n number of such rods in parallel, then K of the equivalent conductivity uh, will be equal to K1 A1 plus K2 A2 plus K3 A3 plus K4 A4 dot 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 up to Kn into An divided by A, means the total cross sectional area of all the rods, and A can be written as also A1 plus A2 plus A3 plus A4 dot 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 anything. So am I clear here, or what? I am clear.